So here's question 6 from part C. It says, what volume will be occupied by nitrogen in a 50-liter cylinder at a pressure of 120.5 atm when it expands into a space where the pressure is 733.0 millimeters mercury? So this problem is the first one that's a little bit more tricky. So again, we have to keep in mind we are using that P1V1 over T1 equals P2V2 over T2. So that combined gas law is what we're using for this whole worksheet. So a couple kind of rules to keep in mind. It gives us volume, it gives us pressure, it gives us a second pressure, and it wants us to find a second volume, but at no point does it mention temperature. So one important thing is that if it's not explicitly given to you, that means you're going to assume it's constant. So since temperature was never given, we're going to assume it's constant and get rid of it. So that means we're no longer looking for temperature. We're not going to worry about temperature. We're assuming it's constant. So we're just looking for P1, V1, P2, and V2. So let's make sure we get these variables figured out. So it says 50 liters of nitrogen. The pressure is 120.5 atm. When it expands into a space where the pressure is 733 millimeters mercury, and it wants us to find that volume. So the thing about this and the combined gas law in general is that you're able to plug in any unit that you like, but the only catch is that they have to match. So we see between our two pressures, they don't match. We have atmospheres and millimeters mercury, which means we're not going to be able to plug in those two pressures. So we have to convert one of them. It doesn't matter which one you convert. I'm personally going to be converting this millimeters of mercury to atmospheres to make it match, because atmospheres is the more common unit and it's the accepted unit across the board for pressure. So to do that, we have to know that 1 atm is equal to 760 millimeters mercury. So this is one of the many conversions that's going to be given to you on your tests, on your quizzes, and all that kind of good stuff. So we're going to take what was given to us, because you always start with your given. So 733.0 millimeters mercury. Follow through just like always. So if we have millimeters of mercury up top, it's going to follow through down to the bottom. We're able to convert directly to atm because we have that conversion. So we know 1 atmosphere is equal to 760 millimeters mercury. So we plug it in, 733 times 1 divided by 760, and we get 0.96, let's go out a third one, 0.4 atm. So we've converted it. Let's rewrite it just so we have all of our variables nice and clear. So now our pressure units match, and our liters or our volume units should match as well. So since we don't have V2, it's going to come out as liters because it went in as liters. But now that we have it all set up, all of our units are matching, we can go ahead and plug it in. So we'll plug in P1, 120.5 atm. The volume is 50 liters. P2, make sure you use that correct one, 0.964 atm. With V2, our volume is unknown. Keep in mind we want to isolate that unknown variable, so we're going to divide both sides by 0.964 atm. So we can get it by itself. It cancels. So V2, let's go ahead and plug it all in. So we say 120.5 times 50 divided by 0.964, and we get that the new volume is pretty large, 6,250 liters. So keep in mind a lot of ways to know that it's liters. ATM cancels top to bottom, you're left with liters. But also our V1 we plugged in was liters, which means our V2 that comes out must also be liters. So that is our answer, 6,250 liters. It is a big increase.